Hello and welcome to the Sum and Difference Identities, Part 1. What we're talking about here is suppose you had the sign, for example, sign of something plus something else. By the way, if you haven't seen this, this is alpha. Okay, I know it looks like a little fish, but it's supposed to be alpha and beta, and it's just like x and y. Okay, they're just Greek variables. So this means, like, say you had the sine of, for example, say you had sine of 10 degrees plus 5 degrees. That's what we're talking about here. How can we expand out this business here? I mean, I know it's the same as sine of 15 degrees, but is there a way I can expand this out? Well, there is. And you have to be really careful because it looks like you just want to kind of expand out the brackets, but you have to follow an actual identity for this. Okay? The expansion looks like this. It's sine of the first angle times the cosine of the second angle plus cosine of the first angle times sine of the second angle. So it's a little more complicated than you might think, at first glance. So in other words, if I was going to expand this out, I would have to do something like this. So this would be the same as sine of 10 degrees times the cosine of 5 degrees plus the cosine of 10 degrees times the sine of 5 degrees. See, I'm allowed to break it up this way. This is how we would expand out the brackets. And I'm going to just list the rest of these. Of course, all these you don't have to memorize. They are all provided on a formula sheet. Cosine, how do we break that one up? Well, cosine of the first angle, cosine of the second, minus, I know this is plus here, but it has to be minus over here, sine of the first times sine of the second. So yeah, a little bit unusual. It doesn't really follow the way sine did. And to make things completely different, along comes tangent. As you will see, it does its own crazy thing. It breaks up like this. It turns it all into a big fraction. Tan of the first angle plus tan of the second angle all over 1 minus tangent of the first times tangent of the second. All right, so these are your sort of three key identities for if you had the sine, cosine, or tangent of two angles that you're adding together. So those are the sum identities. And of course, there are those identities now also for subtraction or the difference. So I'm going to clear the screen and show you what those look like. So we have the sine of one angle minus another angle. Okay? And it looks like this. You would have sine of the first angle times cosine of the second minus cosine of the first sine of the second. All right, so that one kind of looks consistent. You got minus here and you got minus there. But of course, along comes cosine, and it's going to do things a little differently. We're going to have cos of the first times cos of the second, and then plus, of all things, sine of the first times sine of the second. And then, of course, then there's tangent, which is kind of, well, it's very similar to the tangent of when you add the two angles together. It's just got a little bit of pluses and minuses kind of switched around. So tan of the first minus tan of the second, and then all over 1 plus the two tangents multiplied together. So those are what the identities are. And you might think to yourself, well, what good are these identities? They look more confusing than they're worth. But I'll show you what they do for us. So here's my first example. Suppose they said, find cosine of 75 degrees exactly. Not just approximately, but exactly. Okay? Well, the problem here would have been, if we just used the previous learned techniques, 75 degrees is the reference angle. Okay, so you look at this and you go, 75 degrees, what am I supposed to do with that? I don't have a triangle that has 75 degrees in it. And what angles do I have in my special triangles? Of course, we know when we read the word exactly, it tells us we're going to be using special triangles. So you already sort of know, yeah, it's special triangles, okay. But what are the angles in these special triangles, right? So here they are. There's the special triangles. This one here is 45 degrees. And this one here is 60 degrees. And up here we have 30 degrees. Okay, so there's my special triangles. I don't see a 75. What am I going to do? Well, I could do this. Why don't I just take 30 degrees and 45 degrees? Why don't I just add them together? What if I did that? So then I go, hey, yeah, I can do this because I have an identity that tells me how to expand this apart. Okay, so I'm going to go cosine of the first, cosine of the second, minus sine of the first times sine of the second. And suddenly I look at this and I go, that's not going to be that tough. I can just read all of these off my special triangles. Cosine of 30 degrees coming right up, that's root 3 over 2. Okay, so that's root 3 over 2. Yeah. Cosine 45 degrees coming right up, that is 1 over root 2. Okay, just got to make sure to multiply these together. Yep, minus. Sine 30 degrees, sine 1 over 2. Hey, this isn't so bad. And finally, sine of 45 degrees, sine is 1 over root 2. And suddenly I go, hey, this is an expression and it's exact. In fact, these guys have the same denominators. Why don't we make it one fraction? Root 3 times 1 is root 3 minus, and a 1 times 1 is 1. So I go, there it is. There's my exact answer. That is the cosine of 75 degrees as an exact number. So that's what these identities can do for you. They can give you, exact answers when you couldn't have done it any other way. All right, seems like a good place to stop.